Okay, so graphing, substitution, and elimination were our three methods that we used to solve systems. Okay, systems, two equations used to solve one problem. Okay. It could be more than two equations. We're just looking at two this year. And when we first started systems, we used two linear equations, y equals mx plus b form. Okay, but now, since you guys worked with so many other different equations, we're going to use one linear equation and one quadratic equation. Okay, so we're going to use the same three methods: graphing, substitution, and elimination. So we need to graph both of these equations. How do I graph 2x squared plus 1? The quadratic. How do you graph quadratics? We just took the test on it. Yeah, negative b over 2a. Very good. To find the vertex. Okay, and that's going to give you the x-coordinate. So you have, what's b? B is 0. There is no x value. Okay, and then 2 times 2. So you have 0 over 4, which 0 divided by anything is 0. So 0 is the x-coordinate of our vertex. How do I find the y-coordinate? Okay, 0 squared. 0 squared is 0. 0 times 2 is 0 plus 1 is 1. Okay, so that's our vertex. So we can graph our vertex at 0, 1. What did I do to find other points? Okay, above 2 or below 2. I'm going to use positive 1 and positive 2. So 1 squared, 1 times 2, 2 plus 1. So we have 1, 3. And then 2 squared times 2 plus 1, 9. Okay, so we have 1, 3, and 2, 9. And then I reflect them across the axis of symmetry, and in this problem, the y-axis is our axis of symmetry, so I reflect it across the y-axis. And I'm going to do my best to draw a nice smooth curve that connects all of those points. Oh, and that was not my best. That's the paper on, no, that's the paper on the door. Okay. Now, questions on how to graph the quadratic? Okay, slope-intercept form. Okay, that's point slope. Not quite. When you graph a linear equation with slope and y-intercept, what's our slope in that bottom equation, the second equation? Mx plus b, so slope is what? Over 1, right? Negative 2 over 1. Okay, and then the y-intercept? 5. I'm going to graph this in a different color. So now we have start at y-intercept of 5, and the slope tells me to do what? Down 2 over 1, down 2 over 1. And then I can, if I run out of room that way, I can go back the opposite direction, up 2 over 1, up 2, oops, yep, you're right. And then up 2 over 1. Okay, and I draw my straight line with a straight edge. Okay, now, once I have them both graphed, how did we find the solution when we graphed systems earlier? Ireland? Good. You find their intersection point. Okay, but what happens here? We have two intersection points. So we have two solutions. Okay? So our two solutions are both the ordered pairs. So the first ordered pair answer that we have is -2, 9. And then you can also have 1, 3. Both of those are our solutions. Okay? Questions on solving by graphing? Jesse? M is slope. B is y-intercept. Slope, y-intercept. Anything else? Okay. Then we also solved by substitution. So if we solve by substitution, what did we have to have when we solved by substitution? Anybody remember? One of the variables alone. It doesn't matter which one. But in this case, you're going to want y because we're working with x squared. Okay, so you're going to want to get y by itself, and then you substitute it into the other equation for y. All right, so I'm going to box this, substitute it for y in that first equation. So then I rewrite it as x squared plus 11x minus 12 minus 30. I should put that in parentheses. Every time I substitute, I should put it in parentheses. It's not going to matter in this problem, but another problem it might, right? Because there's nothing to distribute here, so it's not going to matter. But just keep that in mind. And then it still equals 12x. What might we do to start solving now? Combine like terms. Good. Combine like terms. And get it equal to what, do you think? Okay. Let's start combining like terms, and then we'll see where we go from there. Okay, so if I put -12 and -30 together, okay, so I have x squared plus 11x minus 42 equals 12x. Do I have any more like terms I can put together? The 11x and the 12x, but they're on opposite sides. Okay. Now, you can subtract 11x. Yes, you can. You can certainly also subtract 12x. Okay? But you're going to want to choose the one so that it makes this equal to 0. So in order to make it equal to 0, which one would we do? Subtract 11x or subtract 12x? Subtract 12x. And any guesses as to why we might want it equal to 0? It's a quadratic function. And I heard a couple of you say that. That's good. Because it's a quadratic function, we just took a test on how to solve quadratics. Now we're going to use one of our 5 methods to solve for x. Okay? So I subtract, now I have x squared minus 1x minus 42 equals 0. Use one of our 5 methods to solve this quadratic. I would always check, can I factor? Are there factors of -42 that add to give me -1? Okay, so if there is, perfect. And then, what, Cindy? -7 and 6. And what else is nice about this one? This function. A is 1. And because A is 1, what can we do now? Very good. You can just immediately go right into your 2 binomials. I split the x into x minus 7, and then x plus 6 equals 0. Did I find my solutions yet? Yes. You have to make them both equal to 0. What property is that called? Good. Zero product property. So I have x minus 7 equals 0, and x plus 6 equals 0. So we have x equals 7, and x equals -6. But we are not done. Why? We need ordered pair solutions. Just like on this last page,